day. Parent functions, part 2. Today we're going to look at parent functions part 2. We're going to look at 4 more parent functions. These parent functions are y equals the square root of x, so the square root function. Then we're going to look at y equals the cube root of x, y equals the absolute value of x, and y equals 1 over x. All right, so each one has a different name. We're going to talk about those, but let's take a look. So starting with the square root function, so the square root function. All right, so the giveaway is the square root just in general. All right, so whenever I have a shifted version of this, we would have something like y equals the square root of x minus some number, let's say 3, plus some number. So this is my graph shifted. Notice that my graph, this would be the graph, this would be this shifted right 3 up 4. All right, we'll talk about shifts later, but notice it has a square root. If the problem has a square root and x is underneath the square root, its parent function is the square root function. That's all there is to it. All right, so when I look at this, adding or subtracting something underneath the radical with it just means it's shifted left or right. Adding or subtracting something at the end means it's shifted up or down. But the x is underneath the square root, so its parent function is the square root of x. So the graph of the square root of x starts at 0, because the square root of 0 is 0. All right, the square root of 1 is 1. And then the next square root that I know is the square root of 4, which is 2. But it would keep going on forever, but it's a curve that goes that way. All right, so the only change of this is if it could be negative. I could put a negative out front or a negative on the x and would change the direction. But notice that it starts and then goes one direction, and it's a curve. All right, it does not go to the left because I can't have the square root of a negative number. So when I'm looking at a shift of this of some sort, it's going to have a new starting point, and then it's going to go in that direction depending on positive and negative. So my graph should look something like this, where it's a starting point and then a curve. All right, so if it's a starting point and a curve, meaning it doesn't have an arrow pointing both directions and it is not linear, it's pretty safe to say that the parent function is the square root of x. When I look at the cube root of x, it's very similar to the square root. The only difference is there's a 3 written there. All right, so that means it's a cube root. Now, I can take the cube root of a positive or a negative number. So this one's going to go all the way to the left, all the way to the right, which technically means it has a domain of all real numbers. All right, so this is the cube root function. All right, and so what this would look like when I write my equation with some sort of shift would be y equals the cube root of x minus or plus some number minus 2. So notice it still says cube root. So if my equation has a cube root, parent's function is the cube root of x. So this is some type of horizontal shift, some type of vertical shift. This would be left 4 units, down 2 units. But notice that I have the cube root of x, cube root of x. Now, when I graph this, the cube root looks similar to the cube function, but it looks like it's been laid on its side. So in general, the generalization of what the cube root function looks like is that. All right, I could also have the negative version, meaning that my leading coefficient is negative, but notice the shape of the graph. So if I have a graph that has a shape like this, I know that the parent function is y equals the cube root of x.
What did 3 say to 4? I'm older than you, 3.
The next one is absolute value. So when I look at absolute value, notice I have these 2 bars. Don't get confused. They're not ones, they are bars. All right, it's a symbol for absolute value. And one thing I didn't say before, a lot of these things, like if you can't figure out based on the equation, you can type the equation into Desmos or a calculator and see what the graph looks like, and then based on what the graph looks like, you can make a decision. But if it's an absolute value equation and it's shifted some way, it's going to have these bars in it, just like the square root has a square root symbol, cube root has a cube root symbol. So if I write this with some sort of shift, this is the absolute value of x minus 1 plus 2. All right, so notice that I have the absolute value bars. So that means the parent function is the absolute value of x. All right, if you see bars, absolute value. All right, the graph of the absolute value in general is a v. Not to be confused with the parabola. All right, but it's a v. So no matter where I move this on my graph, if it's still the shape of a v, it's absolute value. Now, if my leading coefficient is negative, my absolute value could be upside down. So notice the absolute value normally starts at 0, 0. This one has a vertex somewhere else, so it has been shifted in some form or fashion, and it also points down, so that means my leading coefficient is negative. Now, we'll deal more with that when we're actually talking about how to shift things, but it's a v, it's an upside down v, parent function is absolute value. And the last we're going to look at today is the inverse function. The giveaway for this one is notice that x is at the bottom of the fraction. So if x is in the denominator of a fraction, it's automatically inverse function. So it doesn't matter whether something is grouped with the x or not. If the x is on the bottom of a fraction in the denominator, then its parent function is 1 over x, the inverse function. So if we look at this one, here is a number grouped with the x, so that's a horizontal shift. Some number tagged onto the end, that's a vertical shift. Notice x is in the denominator. It doesn't matter whether something's grouped with it or not. All right, so if x is in the denominator, inverse function. All right, when I look at the graph of the inverse function, the generalization, so it's kind of hard to get this one confused with anything because it's the only one that looks like this. Now notice that's two parts, a curve here, a curve there. It has an absolute value, or it's not an absolute value, it has a vertical asymptote at 0 because I cannot divide by 0. All right, so if my graph looks like this where it's two separate parts, curves, it is 1 over x is my parent function. So as I said, all we're doing right now is trying to identify based on the graph or an equation what the parent function is. All right, we'll talk about shifts and all that stuff later.